Good morning, this is your stat sensei, Mr. Spensey, and this is a pre-quiz. This is scenario two. Who used the pool? The Department of Parks and Recreation of a certain city conducts summer programs for residents of its 6 districts. Don't know if that's important or not. Summer program can include operating and maintaining community swimming pools in each of the districts. Their summer programs include operating and maintaining community swimming pools in each of the districts, as well as offering sports and recreation programs for school-age children, young adults, and older adults. More than 20,000 people participate in the summer programs every year. That sounds like a population size there. That's the usage there. The table below shows the proportion of households by district out of all households that participated in summer programs based on an annual data that were collected from simple random samples each summer over a 10-year period ending in year 2000. All right, so we got several random samples down here. The proportions are being used by the city for planning purposes and for more efficiently targeting the introduction of future programs. And we see that 32% used A, 12% of District B used it, 10% of C, etc. All right. City leaders want to test if the proportions that are being used by the city are still valid. They want to see if they're still the same. Data collected by a statistician from a simple random sample this past summer indicated that the following number of households participated in each district and displayed in the table below. So, all right, so this is what happened this past year. So we have these old proportions up until 2000, and then last year in 2023. So we have 100 for A, et cetera, et cetera. The statistician claims that the data for the past summer provides evidence that the proportions that are being used for the city are no longer the same. In other words, they're not the same. Give statistical evidence to justify the claim at alpha equal 0.01. So one thing I noticed is they don't have a total here. And so I'm going to go ahead and I already put that information in there. The 100, the 35, the 40, the 22, the 12, and the 31. And I went stat, calc, one variable statistic, L1. And I looked and I found out, oh, all of those values summed up to 240. Or I could have just added them up. So this is a total of 240. So that gives me my sample size. So my random sample size of size 240. So they want to see if what's happening now is the same as what used to be happening. Well, if they give you percentages and they give you one row of data, this is probably going to be a chi-square goodness of fit test, where we're looking to see if everything is the same as it was before. Does it match? All right, so our hoe. The summer program used by the district, the summer program usage by district is the same as it was prior to 2000. And we probably should have said the summer program proportions would probably have been better. And the summer program proportion usage by district is not the same. Now I'll put the plus and minuses here because the hoe is always positive. So it's is the same. It's a positive statement. Is not the same as a negative. The ha is always stated as a negative. All right. So we need to calculate our expected values. Well, first off, we need to know our total, and we already did that. We said our total was 240. I'm going to go ahead and make a little note to ourselves. And then we need to go back and look at our original tables. All right. So let's go back into stat edit. Well, I've already entered both columns. I entered the observed values, the 100, the 35 into L1, and then I put all the percentages into L2. But those are percentages and they're not expected values. So I need to convert these expected values to I need to convert these percentages to expected values. And I do that by multiplying all of these. Multiply all of these times the total, which in this case is times 240. So I'm going to go up to top of column L2, just arrow all the way to the top, press the blue button followed by number 2, so second 2, times 240. All right, when I do that, they all turn to expected values. They're no longer the percentages. They are expected values. So we can go ahead and go back to that part of our table and fill in that part of our answers. And we go, okay, well, looks like we had 76.8. And here we had 28.8. And here we had 24. Here it would have expected 64.8. That's a big difference. Well, we had exactly what we expected, and here we're slightly off. So this was perfectly predicted. This was way off. This was pretty close. All right. So random sample of 240 that was given, but we had to add that up. We had to add up the observed values, the 100 plus 35 plus 40, etc., to get the 240. We multiplied by 10, and we had 2,400, which is less than the population size, because they told us they expected 20,000 people. All expected values are greater than 5. See table above. Our formula is observed minus expected squared over expected. That's true for all chi-squareds. However, only goodness of fit has this particular degrees of freedom, which is categories minus 1. So we have 1, 2, 3, 4, 5, 6 categories. 6 minus 1 is 5, so our degrees of freedom is 5. When it comes to actually figuring out what we're going to plug into the formula, we only look at the first one and the last one. So we observed of 100 minus the expected of 76.8 over the expected of 76.8 plus plus the observed of 31 minus the expected of 33.6 over the expected of 33.6. Stat, test, chi-squared goodness of fit. That's letter D. Degrees of freedom, 6 minus 1. And we end up getting a chi-squared value of 47.48. And the probability that the chi-squared would be greater than 47.48 is approximately 0. Now, please remember, you'll never have a p-value greater than 1. So if it looks like it is, you probably have an exponent to a negative. And if that exponent, if you have more than 4 zeros, it's 0. All right, we can just call it 0. So in this case, our p-value is less than alpha. So we're going to reject the null. The p-value is approximately 0. We reject the null. There's plenty of evidence. There's sufficient. We have enough evidence that alpha equaled 0.01 to suggest that the summer program usage by district is not the same as it was prior to 2000. Now, where did that come from? That is my ha. The summer program usage by district is not the same as it was prior to 2000. All right. Appreciate you watching. I hope you see you on the next one.